Okay guys, in this video we're going to talk a little bit about conservation of mass and kind of how that works. So, conservation of mass, okay? Like the law says, okay, we're talking about a law here. Basically the law is telling us that if we do a chemical or physical process, matter cannot be created nor destroyed, okay? It must be conserved. All right, so it's a pretty straightforward law, basically saying that if we do anything in the chemistry or physical world, whatever matter we have before, we better be able to keep track of it afterwards. Okay. Now this law is very important to the chemistry world because some of the foundational math that we do in this class is on this guiding principle that whatever mass we put into a chemical reaction, somewhere, somehow, we need to get that exact same amount of mass out the other side of the reaction. So whatever we put in, we better get back out. We can't lose it anywhere. Okay. So sometimes people get this idea of like, well, you lose mass in certain things, and I have students ask me about like, well, what happens when you burn a log, or what happens when you burn a candle, or what happens when, you cook a cake or something, and it's obviously lighter than before, or it's obviously heavier than before. And a lot of times what happens to us is that we do conserve mass in all those cases, okay? So anything chemical, anything physical, cooking, burning, chemical reactions, everything we do in our daily lives. There's nothing in our daily lives that we don't conserve mass. Okay? What happens is, in most of those cases, some of the mass is converted into gas or a vapor. Okay? So when you're baking a cake and you put it in the oven and it comes out and it feels lighter than before, you're like, wow, it got lighter. I didn't conserve mass here. Well, what happened as you bake the cake, some of the gases or some of the liquid in the cake, some of the water, some of the fluid in there evaporated away. So it was still there, it's just inside the oven, or it floated out through the vent of the oven. Okay? When you're burning wood on a bonfire, all that smoke that comes off, all the ash that comes up, all the gases you don't see, there's hundreds of gases you don't see coming off the wood, that all floats away into our atmosphere. It still has mass, okay? Weight not so much, it's light, but it has mass that we don't account for because what's left over in the bonfire pit at the end of the night is definitely lighter. But all that mass is still conserved, okay? So be very careful that not to think that a chemical reaction can destroy mass in any shape or form. Now, that brings up the question, can we ever lose mass? Okay? And the answer to that question is yes. Actually, we can lose mass, okay? Now, it's a very, very, very specific scenario which mass can be lost, and that's if we're able to convert it into energy, okay? So again, don't think, oh, it's a bonfire, it's getting hot, it's being converted into energy. No, no, no. Okay, it's not how it works. In the real scenario, the only time we convert mass into energy, it has to be through a nuclear reaction. Okay? It has to be nuclear. Okay? It has to be fusion, fission, nuclear decay, atomic bomb type of stuff is when we can do these things. Okay? So it has nothing to do with chemistry. Okay? Now, in the world of chemistry, we have a physical process, we have a chemical process, and there's actually a third one that we haven't talked about yet, which is called a nuclear process. Okay? Nuclear chemistry is its own little division, its own little world that all the rules that we talk about in our normal physical world kind of fall apart. Okay? So this law of conservation of mass, it's a law. It's an acting, accepted law in our universe. But, okay, there is a scenario in which this law does not hold true. Now, if you look at the text of the law, though, it actually kind of implies that. In any chemical or physical process, matter is not created nor destroyed. They don't talk about nuclear processes here. Okay, so they qualify it as it has to be a chemical process or physical process. Okay, it doesn't say in any process matter can't be destroyed or destroyed. It says chemical and physical. Okay, so the world of nuclear is a separate division. All right, so can mass be destroyed? Sure. We can do that if we undergo a nuclear interaction like fusion or fission. And in those cases, we can still track the exact amounts of mass that gets lost because it correlates back to the amount of energy that's produced. Okay? And the equation is not hard. It's E equals mc squared. So the mass that's lost, you square that, you multiply it times the speed of light, and that will give you the amount of energy you're going to gain from that reaction. That's why very, very small amounts of mass loss creates lots and lots of energy because we're squaring that number and then we're multiplying it by the speed of light, which is 3 times 10 to the 8th power. Okay? So, take home, conservation of mass holds true. It's one of those guiding principles of all the chemistry that we're going to do in here and a lot of the math that we do in here. But is there a scenario in which we don't apply this law? Yes. So when we do nuclear interactions, we don't apply this law in its normal state. What we do instead is we apply the law of conservation of mass with the law of conservation of energy, and those two laws together can then speak to what happens in a nuclear reaction. Okay, guys? All right, guys, that's it. Thank you.